This is the solution to problem 97 in section P.3. It's very similar to the example that we did in class. So here we're supposed to find the expression for the volume of a box. And we're told that a takeout fast food restaurant is constructing an open box by cutting squares from the corners of a piece of cardboard that is 18 centimeters by 26 centimeters. And the edge of each cutout square is X centimeters. So these are, let's say this is the edge here is X. So each of these is X. And then we're supposed to find the volume for 3 different values for the length of the cutout of the square. So to begin with, we need to find the formula for the volume. So the volume of a box is going to be, and it's going to be a function of X, which is the side length that we're cutting out of the little squares. It's going to be the length times the width times the height of our box. So the length of our box, we can say, is 26 minus 2x times the width, 18 minus 2x, times the height, which is x. And they've shown these, they've drawn these out for us on the diagram that we have. So if we expand these polynomials, we will get the function, and we want to put it in standard form. So first, I'm going to multiply x into 18 minus 2x. So I'll distribute that. So I have 26 minus 2x times 18x minus 2x squared. And you don't have to do it in this order. And now we're going to FOIL those two binomials. So we'll have 26 times 18x. So that's going to give us 468x. Then we're going to do the outer terms. So the outer terms, let's grab those. So that'll be 26 times negative 2x, which will be negative 52x squared. Then the inner terms, so that'll be negative 2x times 18x, which will be negative 36x squared. And then finally, we'll multiply the last two terms. So that'll be negative 2x times negative 2x squared, which will be plus 4x cubed. And now we're going to write this in standard form. So that's in descending order of exponents. So that'll be 4x cubed minus, we can combine the like terms. We have 52x squared and negative 36x squared, which will be negative 88x squared plus 468x. That is our volume for this open box as a function of x, which is the side length of the square that we cut out. And now for the second part of it, we're going to find the volume of the box for various sides of the cutout. So when x is 1, v of 1, we're going to substitute that in. So we have 4 times 1 cubed minus 88 times 1 squared plus 468 times 1, which turns out to be 384 centimeters cubed. Don't forget the units. Okay, when x is 2, the volume is going to be 4 times 2 cubed minus 88 times 2 squared plus 468 times 2. And if you enter that in your calculator, or you can do it in your head, that would be 616 centimeters cubed. And when x is 3, I'm going to substitute in 3 for x into my volume function. So I have 4 times 3 cubed minus 88 times 3 squared plus 468 times 3. And that turns out to be 720 centimeters cubed.